Hello friends, so today we are going to go over Unit 11 data analysis notes. I want to first go over the vocabulary. So right now I'm only going to go over bar graphs. Bar graphs are a graphical representation of data, quantities, or numbers used in bars or strips. A dot plot is a type of simple histogram-like chart used in statistics for relatively small data sets where values fall into discrete numbers. Okay, so here let's go ahead and go to the first page, which is 98. Okay, here we're going to talk about bar graphs. Bar graphs are used to display data in separate categories. Okay, so let's talk about each part of this. If we are looking here, this is going to be the label, which represents what is being counted. Okay, and the scale is how we are counting the interval, like are we counting by twos, are we counting by ones, and so forth. Okay, then we have the title. The title is going to be what the graph is all about. Then over here we have another label, but this label is talking about the categories and what they're about. Okay, and then we have the categories. The categories are going to be what we are measuring. And then, of course, the bars will be representing the total of that category. Okay, so here, let's continue on to page 99. All right, in this first one, we have comparing two different populations. Okay, so Ms. Knobloch conducted a random survey at York Junior High to determine the number of songs in each genre that were downloaded by 40 students. Okay, this right here is the total of students that were surveyed. Now, what I like to do on bar graphs is I like to write on top of the bar strip, I like to write the amount, the number that it is. So like here, this would be 10. This would be 3. And this one would be 4. 11 here, 6, and 6 here. Okay, now that we have that, let's go ahead and look at the first question. Okay, so girls like country music more than all other genres combined. So we're only looking at girls, and what we're comparing is country music and all others. Okay, so it's saying that they like country more. I'm going to circle this symbol, the more symbol, because that is the comparison. Okay, now for country, there is 10 girls. I'm looking at the gray one because that is the girls. There is 10 girls that like country, and all others combined. That means we would take 6 plus 4, which equals 10. And that's 6 plus 4 because 4 plus 6 is right here. And that is 10. Now, this is a false statement because 10 is not more than 10. It is equal, but it's not more. So this is false. Okay, let's continue on to the next question. More girls than boys like rock music. So the category we're looking at is rock, but we are comparing what girls and boys like. So what I'm going to do is I'm going to write girls rock more than boys rock. Okay, now for the rock, there is 6 girls that like rock, and there is 6 boys that like rock. Okay, so again, I'm circling the comparison. This is also false because they are actually equal. Okay, let's go to the next one. Boys like country music more than rock music. So here we're only looking at boys, but we're looking at country versus rock music. So let's write country more than rock music. Okay, for the boys, which is the darker color, there is 3 boys that like country and 6 boys that like rock. Now this is also false because 3 is less than 6, not more than. Okay. Now, let's look at the last one. Boys like rock music more than girls like rap music. So we're comparing boys rock music. So I'm going to write boys rock more than, and I'm going to circle that because that's the comparison. And then girls rap. So here, boys rock, there is 6 boys that like rock. And for the girls rap, there is 4. Now, is it true that 6 is more than 4? Yes. So this is true. Okay. Pause if you need to. I'm going to go ahead and go to the next question, okay? All right, moving on to part-to-part comparisons. Again, I am going to start this off by writing the number above each bar strip. So here it's the amount is money, what we're looking at here, what we're measuring. What we're counting is the 600. Excuse me. 600,000, but instead of writing 600,000, I'm just going to write 6. This one's going to be 4 here. This one's going to be 6. This one is 5. 4 here. 6 here. 6 here. 7, 9, and 8. Okay, now that I have that, let's continue. All right, so expenses have increased 200,000 each year over the last 5 years. Okay, so that means expenses, which is the gray color, has gone up 200,000 each year. But if we look at it, it's going from 4 to 5 to 6 to 7 to 8. It's only going up by 1 each time. So that means that it's not 200,000, but it's 100,000 that it's going up by. So this is false. Okay, let's look at number 2. Number 2 says the income in year 5 was twice the income of year 1. So what I like to do with this is I like to write income, and I'm going to write 5, right? So how I'm going to write that is I for income and 5 for year 5. Now, it's saying twice the income of year 1. So what I'm going to do is I'm going to write 2 times, and I'm going to circle that because that's the comparison. And I'm going to write I1. Okay? Because income of year 1. Now, income of year 5, if I go back and I look at it, income, which is the black strip, is going to be 9. So I'm going to write 9 here. And then I am going to look at year 1, and year 1 is 6. Okay? So if I take a look at this, 9 should be double of 6. But if I do 6 times 2, because remember, I want to know what double of 6 is to see if 9 is correct. 6 times 2 is 12. These two do not match. Okay, so that means this is false. All right, let's take a look at number 3. So number 3 says the combined income in years 1, 2, and 3. So we're looking at income of 1, 2, and 3 was equal to the combined expenses of years 1, 2, and 3. So how I'm going to write this is I, 1, 2, 3. And we are saying it's equal, so I'm going to circle that comparison. And I'm going to write E1, 2, 3 because I'm comparing the income to the expenses. So what I have to look at is income of years 1, 2, and 3. So income of year 1 is 6. Income of year 2 is 6. So 6 plus 6 is going to be 12. And then 12 plus 4 is going to be 16. So, 16 goes here. And let's take a look at expenses, which is the gray color of years 1, 2, and 3. So years 1 and year 2 is 4 plus 5. That would be 9. And then 9 plus 6 is going to be 15. So over here, this would be 15. Now, 16 is not equal to 15. It is actually greater than. So this is false. Okay. I want to go back to number 2, and I want to cross 2x out because it's not a true statement, right? Okay, so here, let's look at number 4. So number 4 says the combined expenses in years 3 and 4 were 300,000 more than the combined income of years 3 and 4. So we are looking at expenses of 3 and 4, which is going to be 300,000 more. So remember, on our bar graph, instead of writing 600,000, we wrote 6. So instead of writing 300,000 more, I'm going to write 3 more. And I'm going to circle that because that's the comparison. For the income of years 3 and 4. Okay, so those are the two things that I'm comparing. Now, let's go back up to the bar graph and let's look at expenses of years 3 and 4. Expenses of years 3 and 4 are 6 plus 7. Now, 6 plus 7 is 13. And then income of years 3 and 4 is going to be 4 plus 6. And 4 plus 6 is 10. So, over here, I'm going to write 10. Now, is 13 3 more than 10? Well, remember, we can just subtract. So, 13 minus 10, that would be 3. So, yes, this is true. Okay, pause if you need to get this down. I'm going to go ahead and move to the next page, which is 100. Okay, now let's talk about dot plots. Okay, so with dot plots, okay, dot plots are used to show the frequency in a set of data. Okay, so here's an example. Okay, the number of goals scored. Each time that a person scored 0, there was a dot placed there. Every time that a person scored 1, there was a dot placed there. Okay, now let's talk about the shape of dot plots. Okay, so here, if you look at the first one, okay, all of the data is more towards the center. Okay, now we can see that this part right here kind of it kind of gets closer to the number line. That is called a tail, and so is it over here. Okay, most of the data is right here in the middle. Okay, so here it's evenly distributed basically. Okay, this is called symmetric. This is a symmetric dot plot. Okay, but then if we look at the second one, it goes like this. Most of the data, it's not evenly distributed. We're going to cross that out and we're going to write data is mostly to the right. Okay, now here the tail is on the left. Okay, data is on the right. All right, so what this means is that this one is called skewed left. Okay, data is on the right, so it's skewed left. The tail's on the left. Okay, all right, now let's look at the last one. The last one, if I trace the data like this, the data is more towards the left and the tail is towards the right. Okay, it's not evenly distributed. Okay, data is mostly to the left. Okay, With that being said, what this means is that this is skewed right. Okay, data is mostly to the left, tell is to the right, so it is skewed right. Okay, pause if you need to get that down, and then I'm going to go ahead and go to the next page. All right, so here we're going to be comparing two different populations, okay? So here, the first thing that I want to do is I want to read the questions, okay? I don't want to do anything with the dot plots yet. There's going to be information from these data sets that we're going to be comparing. So the mode for set A is greater than the mode for set B. So if I look at set A, first of all, mode is going to be the most, the number that pops up the most, okay? So here, if I look at this, I see that 4 is the one that has the most amount of dots. Okay, it has 1, 2, 3, 4, 5 dots. Okay, so this one is the mode. I'm going to write 4, which is the number that it has, okay? Now, set B actually has 2 modes. Now, there can be more than one mode, okay? These are the modes. That would be 2 and 3, okay? Now, is 4 greater than 2? And is 4 greater than 3? Yes, so this is true. Okay, now let's take a look at the range. It's talking about the range for set A is less than the range for set B. Something I forgot to write over here is that greater sign. So 4 is greater than 2, 4 is greater than 3, true. Now let's go back to number 2. So the range for set A is less than the range for set B. So let's take a look at this. When we're finding range, what we're going to do is we're going to take, I want to write this up here. We're going to do greatest minus least, or big minus small. Okay, so what we're doing here is we're going to take the greatest minus the least. So that will be 6 minus 2, which is going to give us 4. Okay, so 4 for set A. Now if we look at set B, this is the big one and this is the small one. Okay, so that would be 6 minus 1, which is 5. Now, is 4 less than 5? Yes, that is true. Okay. All right, let's take a look at number 3. The median for set A is equal to the median for set B. So this is telling me that it's equal, right? Well, now there's a way to find the mode. If you can't do it with them placed like this, you can always rewrite them. And I'm only going to do one rewritten, okay? But I'm going to show you the way that I would do it on here, okay? I'm going to use the red highlighter. Actually, the purple highlighter. Yeah, let's do that. Okay, so here, crossing off this one, this one, this one, this one. And all I'm doing is continuing to cross off until I get to the 2 middle numbers, which are these right here, okay? So normally what we do is we take 4 plus 4, which is going to equal 8, divide that by 2, and that is 4, okay? So 4 would be the median. The reason why I'm bringing this up is because sometimes you will have 2 different numbers. You have to add them up and then divide by 2, okay? You're finding the average of the 2 numbers, okay? Here, it turns out that it's going to be 4 regardless because they're both 4, right? So I'm going to write 4 right here. Now we're looking at the median for set B. Here is where I'm going to do this a little bit different. I'm going to erase this. I should have moved it. Let me move it over here. Okay, and I'm going to rewrite every number. So 1, 1, there's 4 2s, there is 4 3s, 1 4, 2 5s, and 1 6. Okay, now this is going to be a little bit easier for me to cross off, because sometimes what I have noticed is that even myself, I do it, is because they're kind of this way and that way, it's kind of hard to keep track of what you're crossing off. But this way, I can just go like this. Cross off on both sides until I get to the 2 middle numbers, which is 3 plus 3. Now remember, 3 plus 3 is 6. 6 divided by 2 is 3. It's still 3. Okay, so here is 4 equal to 3. That is false. It is not equal to 3. It is greater than 3. Okay, now let's take a look at the skewedness of set B. Okay, so I'm going to use a yellow highlighter. Okay, now here, if I trace the data information, okay, most of the data is going to be to the right, to the left, and the tail is to the right. Okay, so that means that it's not skewed left, this is skewed right because the tail is on the right. So this one is false because it's not skewed left, it is skewed right. All right, now that we have that, let's move on to the next part. Okay, take a moment to pause if you need to. I'm going to go ahead and move to percents from dot plots. Okay, so we are going, I'm going to show you 2 ways. Okay, I'm going to show you the harder way first, and then I'll show you the other way that you might end up liking and using more. Okay, so let's look at the first question. It says, what percentage of people surveyed had 2 brothers and sisters? So looking at this, the first thing I want to do is set up a proportion box. Okay, it'll be number 2% part to whole. Okay, so I need to count up all of these first. Okay, so that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 goes right here. Okay, and then the next thing that I need to do is find out how many have 2 brothers and sisters. That would be 1, 2, 3, 4, 5. So 5 goes right here. Now I'm trying to find percent, so X goes right here on the percent, which is the part, and then 100 goes in the whole. Okay, now what we would do is cross multiply. So that would be 15x equals 5 times 100, which would be 500. Now all I have to do is divide by 15 to get x by itself. So 500 divided by 15. I know that 15 times 3 is going to be 45. Subtract that, I get 5 again. Bring down the 0, I get 50, so that'll be 33. I'm going to stop there because it's going to keep repeating. So what I'm going to do is I'm going to write 33%. This is my answer. Okay, this is basically cross multiplying, setting up an equation and solving for x. Okay, now I'm going to show you on number 2 the 2 ways that we can solve this. Okay, now again, first thing you want to do is set up a proportion box. Remember, number here, percent here, part to whole. Okay, and the first thing that we need to do is count up all the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 goes here, and it's asking us to find the percentage of people that read 7 or more books. So all that is this part right here. Okay, so there is 1, 2, 3 people that read 7 or more books, we are trying to find the percent out of 100, okay? So, just like the one that we previously did, we would do 20 times x, which would give us 20x, equals 3 times 100, which is going to be 300. And then we solve for x by dividing by 20, okay? So 300 divided by 20. 2 can go into 3 one time. Let's do this like this. 3 can go into 20 can go into 30 one time. And then 20 can go into 100 5 times. So that would be 15%. Okay? That is correct. Hello? Okay. All right, now I'm going to show you the other way. I'm going to do this one in green so that y'all can see it, okay? I'm going to set up the proportion the exact same way, okay? 3 out of 20, x out of 100. But here's where it's going to be different. Instead of cross multiplying, I'm going to find a relationship, okay? I can check 3 to 20. It's not going to be easy for me to multiply 3 by something to get to 20, but I know that if I take 20 and I multiply that by 5, that's going to give me 100. So that means on the top, I would have to multiply 3 times 5 to get 15%. So x is equal to 15%. Done. Okay, so this method that I just showed you right here is called finding the relationship, okay? This right here is cross-multiplying, writing an equation and solving for x, okay? If you can see the relationship, by all means, use this way, okay? But if that's hard for you to see, then just stick to writing the equation and solving for x, okay? All right. These are the notes for today. Pause if you need to. Get this stuff down. I will see you in the next notes. Bye.